Hello, hello. Good afternoon. This is Sean Ashcraft, and today I will be practicing a presentation that I'm planning on doing pretty soon for some students. It's Audio 101 or Crash Course in Public Broadcasting Audio, something like that. So let me switch to the desktop. Hey, I got OBS still open here, and I'll just dive right into the presentation. I don't really need to set things up. Just start things off. I haven't really practiced this. I guess I put this together in May. As a practice, I'm just gonna stream myself doing this presentation. So thanks for joining me and thanks for your attention. Again, my name is Sean Ashcraft. I work at Indiana Public Radio and Ball State Public Media. IPR is the radio part of Ball State Public Media, and this is a crash course for PMX students who are possibly going to do audio stuff, or if you're not going to do audio stuff, that's okay. This is just a bunch of fun stuff that you can learn. This is going to be an intensive crash course. I'm going to cover a lot of ground. I don't expect you to be an expert by the end of this, but I do want to expose people to these concepts. So the first half is going to be a bit more technical. The second half is going to be a little bit more practical. But let's just dive right in. So I always like to presentation signal flow. I always like to kind of outline what I'm going to talk about, not only because it gives you a preview and you kind of think like, oh yeah, this is going to be a boring presentation, or oh great, this is going to be super awesome. And it also just reminds me what I should focus on. So like I said, we'll learn what audio is, we'll take a look at some tools, some practical stuff, and some need-to-know information if you're working with audio, which is a lot of people. So first of all, what is audio? So we just grabbed the Wikipedia, cheap definition of what audio refers to, and commonly audio, when you say audio, we're talking about sound as it's transmitted or stored in signal form. So we have various signals that represent real life sounds. So sound, if you don't already know, consists usually of air pressure waves. So as air pressure changes over time, with little tiny variations, kind of like the background of this picture right here, or this slide. That's kind of how sound travels through air, or if it travels through another medium like water, those are water pressure waves. And those changes in air pressure over time is what the human ears process. And so they create little signals that go to our brain. So in a way, audio, not the same kind of audio, but a different kind of audio is going on in your brain so that we can hear things. Most doctors don't talk about the sense of hearing as being audio, but if you wanted to conceptualize it that way, it's not totally wrong, I think. But we're not we're not too concerned about human perception. We are a little bit, and I'll get to that later, but the big thing we're going to focus on here is like, what is audio, what is sound? And the two endpoints, I would say, when you have audio systems, is you pretty much always need something that can measure sound and something that can reproduce sound, and those are the microphones and the speakers of the audio chain. And so I'm going to eventually get to a whole audio chain, and we are most concerned about what happens in the middle of that chain as media professionals. But first, let's just get some understanding of what's the beginning of the chain. Let's take a look a little bit at microphones. So the technical explanation of what a microphone is a transducer. All that means is it gets air pressure, changes happening on some sort of medium or membrane, and the transducer element of it converts that to electric signals. And I am not aware of a purely digital microphone that can instantly convert air pressure changes into digital signals. There's always some sort of element in there that has like an analog signal that represents the air pressure. And then there's usually some sort of process to convert the analog signal into a digital signal. And I'll get a little bit more on that later. But the reason I say all this is because microphones, most of the time, they are producing an analog electric signal is what their output is. So, and just a couple of things to keep in mind about microphones. They only pick up sound in one point in space. You can have shotgun microphones, and those are kind of aimed or directional, and they're really good. For example, this microphone that I'm talking into for this stream, it's directional. It likes to point at my face. And if I talk into the back of it, it does not sound correct. It sounds like I'm in the back of the room. It's because this is a very directional microphone. Yeah, I just wanted to pick that up, just kind of point that out. And also, it sure seems like shotgun microphones can pick up sound really well from far away. But again, that's that directionality, and it doesn't really... So what I'm trying to get at is the closer you can get a microphone to a source, generally, the better you can pick up that particular source. So just a little tip in there. And also just a tiny thing to keep in mind is the electrical signal that a microphone creates is usually really, really tiny. So you usually don't get shocked by microphones unless you have some really weird setup. The other end of the chain are speakers, and usually we think of these as, like loudspeakers or headphones. So a speaker is really just the opposite of a microphone. It is a transducer. It's also a transducer, but what it does is it moves air pressure, or it moves air and it creates air pressure. It creates sound waves based on an electrical signal telling it what to do. And usually that electrical signal, again, is analog. There's very few true digital speakers when the actual action of the speaker is digital. Most speakers are analog, and they're actually moving in proportion to the sound. So speakers, they just create sound in one point in space, and they need a big enough signal to push the air out. So it's another little tiny difference between microphones and speakers is microphones don't really need to be powered that much. Usually it gets complicated, but speakers, they do need a little bit of power to actually do the thing that they need to do. So this is pretty much what we're getting at. We were just talking about, the endpoints. And so I like to think of it as there's media, technology, and there's people or the environment. So usually microphones are picking up sounds of either people or, the natural environment. That's converted into some low power audio that hits various different types of media and processing. And then if we want to hear sound from the media, we need to convert, those signals into a signal powerful enough to drive a speaker. And then the speakers make sound and make people happy, or they make people upset, or whatever. They provide sound for people. So continuing our crash course here about audio, I was getting at there's basically analog audio and digital audio. I've got a lot of information on here, but basically the analog audio signals, they are in proportion to the air pressure changes, ideally. A really good analog system will pretty much perfectly or add some cool effect to the real sound of the air. Ideally. So media for this includes anything that can move an analog signal, which is stuff like copper wire or over-the-air radio and stuff like that. Grooves and vinyl records are kind of, they're pretty much analog. It gets a little fuzzy because there's actually kind of a spectrum between analog and digital and kind of some different ways, but I won't go that deep today. So the other type of audio is the binary representation of analog signals, which is digital, and there's all types of formats for this. So we're living in the digital age, so we're kind of familiar with computer hard drives and the internet and the cell networks and all that stuff. That's all working with digital. I wanted to go a little bit deeper into audio signals because I'm that much of a nerd, but I wanted to kind of connect the dots between what I was just kind of talking about, like the proliferation of computers and digital devices, and that it's kind of handy to have an understanding of how audio usually works with digital devices. So I found this on Wikipedia, and it was kind of hilarious, so I wanted to include this in my presentation, but it gets at a lot of the key concepts that I just went over. So like, there are microphones that pick up sound. They are converted into electrical voltages. On the other end, electrical voltages are sent to speakers, which then create sound. And then in between is kind of where computers can play a role. You may be familiar with kind of some concepts in computing, like basically, if you can compute something in one digital environment and it has enough resources, you can compute the same thing in a different, hardware. And so, this is the backbone of computerized internet, stuff and all that. But yeah, audio is treated just like any other digital data signal, and in fact can be combined with other data sources and all that fun stuff. So if you just think of what is a computer when it comes to audio stuff, we've got the analog to digital converters and vice versa, digital to analog converters. And then once analog audio is converted to digital and it's good quality, we can kind of, digital processing, but also the arrows on this diagram pointing to different storage devices. What's implied here is that now this media can be transmitted in so many different types of forms. They just have a lame example here of just a hard disk and an iPod, because I guess this came out like 15 years ago. But if you kind of abstract it just a little bit more, you think of computers as basically, CPUs, a computer or a central processing unit, and it does logic and it has memory, so it has storage. If you abstract these input and output devices, you can start to think like, all right, so there's audio interfaces specifically designed to work with audio. There's also network interfaces or, internet interfaces that are specifically designed to work with data. So there is a connection between those. And so that's just a little bit of technical background. I don't want to go into all the details of it, but I just wanted to kind of point out some of the tent poles or cornerstones of the digital revolution and all that fun stuff. So this particular architecture right here is called von Neumann architecture. And it's kind of a generalized, here's what all computers do. They're all this: input, output, memory, digital processing or logic processing, arithmetic processing. That's basically it in a nice little package. So from here, I have a little bit of extra detail kind of geeking out on this idea of just this helpful generalization when you're working with computers. So when you are in the digital kind of like computer desktop GUI environment, when anything is represented as an abstract data collection, pretty much everything in a computer system is a file somewhere. So we're talking about media like shows or recordings or pictures or videos, even live streams. In a way, they can be represented as a file in a computer system. So if we had to like have a generalized computer world, and we had to be like, okay, what's the one thing that we can put into memory and send in the input-output devices? It's a file. Whether that's a text file or an MP3 file or a doc file, they're all files. So I have some more thoughts in here about that, but I don't need to dwell on this. But just that sometimes surprises people. When you say a live stream, what are you really talking about? You're actually talking about small packetized chunks of audio data. And that audio data, how do you know what it is? Even though it's a live stream in a computer world, is like, how do I find this thing? That thing that you're looking for is a file somewhere. Maybe it's on the internet. So I'm not going to go much deeper than that, but that's basically it. And what are computer files? There's header and data. I don't have to really talk too much about that. So let's talk about audio files. Again, I put a ton of data in here. Let's just get the top points here. First of all, there's sort of your production formats. These are the formats that you want to use so that you make sure you are getting all of the audio quality. You're not losing audio quality. And if you have a format that's consistent, you don't have to waste a bunch of computer resources like converting files. So if you have a standard format, it's usually, and it's a lossless, you want no loss just from putting it into the format. This is the way to go. So the two big ones that most people use, .wav or .aif is like the Mac version of .wav, although Macs can work with .wav files and Windows computers can work with .aif files and so forth. What's important with these are sample rate. Not going to talk too much about it, but basically more samples, more frequencies of audio. 48K is the best. You could have more. I don't need to go into all that, but bit depth, how precisely to measure the signal to noise ratio. 16-bit is sort of like the industry standard minimum for an audio file. It could be more. That's fine. Then you have sort of your consumer formats. These are lossy. They might drop some data that you can't even hear, but so they're a lot easier to share over the internet and that sort of thing. The important thing to keep in mind with like MP3s, or if you're working with the AAC format, I know it says M4A, but advanced audio codec is what it's just the file type. The important thing with this is bits per second. So I'll get on more of that here in a little bit. So I was kind of touching on production and distribution formats. So here are some details if you want. This is my recommendation for just general production, whether that's high quality music or interviews or just everything sounds great at 24-bit 48K wave. Don't even really need to think about it. Sure, you can do more samples per second if you're like in a super high quality, studio environment, and then it's debatable as to, whether you can hear a difference, but I'm not going to argue that today. Then for distribution formats, these are usually really big audio files that nobody wants to sit there and download. So we use stuff like MP3 and AAC. 128 kilobits per second is pretty good. You don't have to think too much about it. 320, if you're an audiophile like me, that's like the highest setting that these go. And there are these in-between formats like FLAC that preserve all of the high quality for production, but they're smaller. So anyway, I don't need to talk about those today. I do want to skim over the audio hardware tools that we have here at the radio station, just to give you a feel of like just how wide-ranging the technology is, and you could spend a long time studying every single component, or you can kind of approach things from a bigger perspective of like, okay, this microphone is directional, or this microphone is super high quality, but it costs a lot of money, so you don't want to break them. So you don't want to buy like a bunch of them to take out into the field. You can spend a ton of time trying to understand these things. But I think the big picture we've pretty much covered is in terms of the technology, and I'm not talking about like production techniques or anything, but, the secret formula to good audio is get mics close to the source, make sure you process them in a consistent way. And when people want to hear sound, they want to nice consistent listening experience. And they want it to kind of sound like it did originally, but they want all the distractions gone, and folks like, again, like I said, that consistent listening experience. They don't have to crank up their headphones to hear the person in the back of the room, or that sort of thing. So I was going to skim over this hardware. We have plenty of studio equipment for everything that you could possibly think of. Field equipment, which might be used a little bit more by like TV crews and general audio folks. We've got very high quality, wrong way, microphones and that sort of thing. Field recorders, we've got decent field recorders. I probably should update this because we've got some newer stuff recently. Live feed things, mixer. We have like all of this stuff. So I just kind of threw these in here as sort of a review, I suppose. And then on the software side, this kind of connects a little bit more in like the day-to-day media stuff. So in our studios, we have drivers that basically magically get the audio from all of our devices into computers and all the stuff. And then once audio's in on a computer, you want to manipulate it using like a digital audio workstation or record using this. So we currently use Audacity and Audition. I'm kind of working on like the free version of Pro Tools, but it's complicated, so I'm not trying that hard. And then we use this free effects bundle to augment the digital audio workstations. I probably won't talk about plugins today, but they help automate a lot of stuff, basically. And then to keep the radio station on the air, we have an automation broadcasting system, and I guess I threw OBS on here because I use it to stream to YouTube, because why not? Some other stuff, OneDrive, Slack for communication, and then for the radio distribution, we get programs from the satellite system and over the internet. Okay, so here's kind of the more practical. All right, I'm producing audio, I'm recording stuff. I don't know if it sounds good or bad. What do I need to know about audio quality? Sounds pretty good to me, but then, my friend's like, hey, that should sound louder or whatever. Like, what are they talking about? So before we can understand what does it mean to have quality audio, let's try to understand what quality sound is. So what does sound consist of? So let's dive into, some of the details. So we've got your pitch of sound. My voice is kind of a low pitch, but whenever I make an S sound, that's like a high pitched thing. So sound can have low or high frequencies, and when we're thinking in terms of natural sound, we usually refer to that as pitch. Duration, how long something is. Loudness, how much energy have I put into it, or how loud is something perceived, even if it's low energy. So like the S's sounds, even though I've got some processing on, they might cut through, their level might be down here, but because it's like a bright S sound and human ears are tuned at certain frequencies, we might perceive that to be a lot louder than, a meter might tell us. Timbre or texture, this just has to do with all the different sounds and pitches combining together. And then spatial location, there's a few different ways that humans perceive like where sound is coming from, but basically it's the fact that we have two ears. So that's the easy explanation there. So let's flip that thinking over to audio quality. So those are sound qualities, what humans would, say, that spatial location, it sounds like the person's talking right in front of me, or it sounds like the person's just talking on my right side, which is kind of unnatural if I'm expecting them to be coming out in front of me. So that's an audio quality topic. The timbre, it's Sean's voice is harsh and just jar, I just can't stand how, just sounds like, nails on a chalkboard, So that would be a bad timbre or a harsh timbre, or, the more that you can describe it, the more that you can put a quality to it. So, or loudness, I know I'm going on things that seem like they're simple, because when we're out in the world, we naturally understand these things, but it's really interesting to be like, yeah, these are natural things you would expect from sound, and then to see like, okay, how is that treated in audio, and how can we have that experience be consistent and something we expect or professional? It's definitely related to these sort of things. So, and I think loudness is another one of those things that really plays a big part in that. So let's kind of translate those sound qualities to audio. So pitch in an audio environment, we would consider frequency range, or the amount of bandwidth that we would have available. Duration is the same, time in reality is the same as time in media, except media can be sped up and slowed down and all that sort of stuff. But is the length of time what we expect? That's a factor. Loudness is not necessarily the same as the audio level. And so usually these comparisons in textbooks will say, okay, sound and loudness, cool, that's the same as the level that's on the meter. No, not quite, because you're talking about a representation of a signal versus the loudness perceived by a human. So actually all of these factors have a human perception component to it. For example, frequencies. Radio works on frequencies, right? Like 92.1 megahertz. But that's such a high frequency that there's no way that humans could hear it, even if it was interacting with the air pressure waves, because of the extreme high frequency. So human perception is the reason why we can't hear radio frequencies. We can hear the result of the radio system, but not 92.1 itself. So, and then timbre and texture, that's related to the frequency and bandwidth of the signal. And the spatial location, we get spatial location due to the fact we have two ears. So we use a stereo technique to kind of simulate humans. So here's a bunch of tips in here that I'll kind of use to fill out the rest of the time. So if you're trying to think about frequency range, bandwidth, this is where I can kind of open up some like examples. So if you are working in Adobe Audition and you're like, okay, I am going to start a new session, but what it's going to ask me, what bandwidth are you going to work with, and what bit depth do you want? So let me multi-track. So here I can see it says it's just suggesting 48K 24-bit, because this is what I always use. So yeah, and then the mix stereo, there's a 5.1 standard. There's a lot of other standards out there that I don't remember how you put that in Adobe Audition, but 24-bit, 48K. I mean, this is the frequency range that we're talking about. And then 24-bit's kind of related to the bandwidth. If you're talking about like the bit depth, bandwidth, you get really deep into the telecommunications theory, and it gets really complicated really fast. But so that's my first tip. When you set up your session, use a really good bit depth and frequency range. 24-bit 48K is a pretty good happy medium. I would say the minimum would be CD quality when you're working in production. So at minimum, like if you're out and you're like, I want to make sure I get a lot of good audio, but I'm worried on how much space it's going to take up, maybe use the 16-bit 44.1 wave file standard. Often these programs will just default to the maximum setting. And 32-bit flow, there's nothing wrong with that, except now all of your audio files are like way bigger than 24-bit. And then the sample rate, same deal. 48K, pretty good sample rate, in my opinion. These other sample rates might not be supported by a lot of hardware, like 44.1 and 48K are the standard sample rates. These are professional sample rates, and you kind of have to be careful using them, because if you don't use them with the correct kind of hardware, you're just going to end up with huge audio files and possibly even distortion and just alias, and just not everything works that great using these sample rates. So I would rather work at a sample rate that I know the hardware will be able to work with. And this has kind of been the case. If you've got like a real expensive, professional, high quality, go for it in that case. But standard, everyday use, 20-bit, 24-bit, 48K is good enough. Then on top of that, use a really good quality microphone close to the source, wind filtering so you don't pop anything, or you don't have a wind noise. And then just some common things that media people run into, and they're like, how do I fix this? And I'm like, well, you gotta figure out how to fix it. Boomy sounds, popped P's, learning how to use something simple like a high pass filter on an EQ. That fixes a lot of problems. And it's not going to fix all your problems, but it's going to help. And then if you really want to get into audio geekery, you can craft, your tone with EQ. You got to watch out for aliasing, like I was talking about. And it's helpful to know that noise, like human ears, are kind of tuned to pick up frequencies around 4K. So that can be useful both for what should I filter for noise. And you really shouldn't use like a high or low pass filter for just broadband noise. You kind of want to use something more advanced, like a spectral noise processor or a level gate, or expansion or something like that. So it just gets, like I said, it gets super complicated super fast. But these first 3 tips, close to the source, wind filter, good quality audio settings, and maybe throw a high pass filter in there if you don't want that bass boominess. Those are some easy tips. Duration. So I'm going to get into broadcast format mode for a little bit. One thing I will say, actually, I do have a tip down here for it. So with duration, if you're working like in a broadcast, like it's going to be scheduled on air environment, know what your broadcast window is, and if there's a clock to the show, that just means here's the timing information for your show. Just know, like, respect that expectation. So here at IPR, if we ask for a 30-second spot, that's really something that's like a little bit short of the goal time. You don't actually want to hit the goal time straight on. Kind of want to be like a little short. And again, this is just radio tips. Even other radio stations, depends on what environment you're in, they might have different expectations. So here we're like, just be a little bit short of the goal time, and then that's perfect. And I even mentioned here, they might trim stuff, maybe they don't trim stuff. You don't really know what they're going to do. So if you give them something that's perfect for them to just drop right in, that's great. TV might have different expectations. So this is where we're talking about radio. And then I also just have a tip in here about silence. If you deliver something and the last 5 seconds of it are silent, it's like, this isn't a 30-second spot. This is a 25-second spot, and the last 5 seconds are silence. Like, what do you want me to do with this? So in broadcast world, like if something is silent, like that's usually like, why is this silent? Now, if the content is asking for something to be silent, like I need to take a pause to really let this thing I said sink in, then that kind of silence, I would keep that kind of silence in production. So, and maybe like don't have more than a couple seconds of silence. I don't know, if you have to have it. So loudness and levels, I have so many thoughts about all this stuff, but I think it's the big picture thing is to kind of know the difference between audio clipping, which happens when your signal level's too hot, and then the perceived loudness consistency. So I have some, information on here about why we use loudness meters. I won't go into like all of it, but basically what a lot of TV stations and productions, what they're expecting is when you deliver a big old audio file, they want the integrated loudness to be at a certain setting. And at IPR, we want that to be at negative 24 LUFS, because that's what NPR does. And then when we deliver stuff to the web, it doesn't really matter. Except what does matter is what platform are you posting it on. So let's say you're delivering something and you want it to compete with everything else on Spotify, for example. Go to Spotify, maybe measure some audio levels of just, stuff that you would want to be around, whether that's a podcast or music or whatever. And you'll start to notice stuff on the web tends to be around like negative 16 to negative 12. So that's a lot different than the broadcast standard. And that's just a reality of if you're working in the broadcast world, there's just different standards. You can have a standard for broadcast, and the web, there is no standard. But the idea of a standard is the audience. What are their expectations? Do they expect stuff to be really, really loud? Do they expect stuff like, I got to crank this up all the way to be able to hear it? So that's kind of where, a lot of people don't know what to do for the web, but they're locked in with, okay, broadcast, I know what to do there. Web, I don't know what to do. I'm scared. If you just kind of get it into a competitive range, I think that works. Spatial location, just keep speech in the middle. It's very distracting to hear one person talking in my right ear and another person talking in my left ear. But you can use that creatively. So it's a creative thing, but the standard thing for speech, keep speech in the middle. If you're doing a surround sound mix, they usually have a speaker dedicated just for speech, and you leave it in there because then it syncs up with the, what's on screen. You can do other stuff, obviously, but only do spatial location stuff when it's intentional, is what I would say. So what other kind of audio quality standards are there? Here's my summary. That's just a summary. We just went over that. And then something I wanted to mention too, we've been talking about audio. The audio files, digital audio, usually has metadata along with it. So this is where there's another big difference between what broadcasters decided to do and what the whole rest of the internet decided to do. We use this obscure thing that was developed back in the 90s called cart chunks. I mean, MP3s were developed like in the late 80s and the early 90s, so I shouldn't. But anyway, cart chunks are what NPR uses, and I'm not even going to try to start to talk about that. But MP3s they use what are called ID3 tags. I think AAC uses ID3 tags too. So I'm just going to say that those exist. There are a lot of other systems that seem like they're metadata, but they're actually just databases referring to audio libraries or whatever. The whole idea with metadata is so that you can manage a large library and you know exactly what the audio is. So any kind of media comes with metadata, and my advice generally is just spend the time to research it if it really helps you manage what you're working with, or it just is more appealing for a final product if it has good metadata. Often big, plants or whatever will have standards, or they'll just have systems that automatically handle a lot of metadata, and it gets really confusing and stuff. So that, I guess I'll just really quickly kind of point out how you can do this stuff in Adobe Audition, since that's the thing so we did this guy, quality microphone close. I guess this is my demonstration of that. Filter out boomy sounds. So let's say I record some audio. I'm going to record a mono source. So I'm just going to pick the left channel from the stereo pair. I could sum them together, but I always just pick one. just in case there's any sort of like weird left-right mismatch. I don't know. There never really is. Anyway, here's a little bit of audio here that I'm recording, and we will, I'll show you the, a couple different ways you can filter out boomy low frequencies. I'm trying to think of putting up like pop a P somehow, but I have the wind filter on, so I don't know. We'll see what I can do with this. And so if you're working like in a multi-track session like this, you usually for each track in any DAW, you have an effects rack. And if you look at it in the mixer, the effects rack is up here. Basically, the audio will pass through each effect one at a time, starting with the top going down. So let's say I wanted to put on some EQ. I could use the built-in EQ for this channel. This is probably the easiest one if you've never done this before. Just fire this up. And this is kind of cool. It's got a live analyzer. But let's say I've got some really bad audio and this low stuff is like really causing problems and really annoying me. When I stop talking, you'll actually be able to see what's called the noise floor here. So maybe like there's a hum or just some really annoying like low frequencies, which sometimes causes just problems. This HP button right here is the high pass filter for this effect. And then I can just go and I can scoot this up. And if you could hear what I'm doing here, basically it's filtering out all the slow frequency. You can't hear this right now because I don't have it routed that way, but you basically would not be able to hear the low end of my voice if this was the case. So I think this analyzer shows me, let me do this. Check 1, 2. Oh yeah, it's like post. So you can see how now the frequencies are all rolling off there. So if I set this just below where my fundamental is, a lot of people like to put high pass filters around 60 or 70 or 80 hertz to get rid of that rumbly. But if I set it a little too high, then it starts getting rid of my low end. So I would probably just want to put that right above it. So that gets rid of like boomy sounds. It doesn't fix all of the popped Ps and things like that, but it certainly helps. Standard broadcast lengths. This is a little bit easier to see with a clip here. So let's say I was expected to deliver something to 15 seconds. Here's a little bit of silence, which might actually sound fine if that's what we want. But generally, I'm not going to give you a Adobe tutorial today, but this is kind of what I do is add a little fade, make sure my timing is something I can make sense of. And let's say I needed to be 15 seconds long, and let's pretend like I didn't talk here. This would be if I said, hey, give me a 15-second spot, this timing somewhere between 14 and 15 seconds and kind of more on the 15-second side of things, this timing would look pretty good. But let's make sure that we mix it down in such a way that we can guarantee that we've delivered the correct length. So I'll just go to mix down. We'll just do the entire session. Okay, cool. Oh, look at this. If I go to the end of the file, whoa, it's longer than 15 seconds. And that's, sometimes software will just do that. It'll add a little bit of buffer time. So I haven't quite saved this file anywhere yet. So what I can do before I save it is I can highlight and I can try to find, all right, it's totally silence here, delete that. And if I'm super paranoid, I can add just a little bit more of a fade to make sure everything fades out there. And there you go. Duration is 14.9. I think it was 14.7 earlier. But yeah, you can see how there's a little bit of, stuff there. Maybe this, if I really wanted to get this tight, I could just delete that, fade this in. Normally I would say listen to your audio, but I just can't play. I just don't have it set up to do that right now. So, and then the expected loudness curve and how consistent is your loudness. So real quick here, Adobe Audition has a couple tools. So let's say I'm in my my mix down. They have this very easy tool called the amplitude statistics window, and if you just get a file open, scan it, and then this little number right here, -21, that's the calculated loudness of this whole clip. So if we're shooting for -24, do a little bit of math. Difference between 24 and 21. Anybody? It's 3. So I would turn it down 3. So that way 21 goes down to -24. Sometimes I will forget to say the negative, and that confuses people, and I'm sorry. But yeah, -24 now, because we turned -21 down to -24. And it's good. And you can see how the peak is not anywhere close to what this is. Peak value, if I look at the meter here, yeah, that's around like 9. Loudness, however, is matched to the target. So then you want to listen back and ask, is this consistent loudness? And by that, I kind of mean like if you're in your session, this part here looks like it's louder maybe than that part. I don't know. So then you would want to go in and kind of mix your stuff. And, oh, this really needs to be turned up. I don't know, 3 dB. And then this is too loud, and turn that down. If you don't like doing this, you can learn how to use a compressor, and it automatically does this for you. Or if you just want to turn stuff up and down, that works great too. Oh, and then the stereo field. So that's what panning is all about. So if I pan, you won't be able to hear this, but if I pan it all the way to the left, only the left side would have my voice, and then the right side. So generally voices go in the middle. Yeah, and specifically, don't just have left only audio. I hear that on productions that don't have like the highest quality production, and it'll be something that's like really great, like really well produced, and then it'll just be like one spot where somebody is only in my left ear, and I'm just like, did they not notice? But it's an easy thing to miss too. So I'm not too, no judgment if it happens, but. Okay. So I guess the end of this is to answer any questions. But there's nobody here to ask them. So do I have any questions for myself? Did I do a good job? Let's look and see. What am I looking and seeing? I guess reviewing. Did we answer what is audio? I think so. Do we look at the audio tools? Yep. And what do they need to know? Make the audio quality. Just like this. This has quality audio, I think. Am I doing all of these things? Well, since this is a live stream, it's a little different. But what's good to know is this whole system is, in fact, the Axia system is a 24-bit 48K system. So that's pretty cool. I'm using a good quality microphone. In fact, there is a high-pass filter on the preamp, I think. Yep. So I've already, even with the pop filter and everything, there's no bass, there's no boomy sound. Distractions, I didn't really talk too much about that, but, do your best with those. This live stream definitely does not match a standard broadcast length, and it's definitely out of tolerance. But when it comes to expected loudness, I think I've got this tuned to be pretty competitive with most other streams. I might not always be hitting, I don't know where I'm hitting, to be honest, on this. I guess I can measure it. So here's an easy way to do that. It's just got your audio input. Adobe Audition comes with some stuff like the loudness radar meter. And there's another one. Why am I having such a hard time finding it? There we go. Just a normal loudness meter. Okay. So it looks like if I'm just kind of talking and sustained talking after a while on this radar meter, I'm kind of sitting around -17, which is, it's not -24, but it's not -12. It's, somewhere in between. You can even see on the radar meter here, like -12 is sort of toward the top. -6 is just about the loudest thing that you could possibly imagine coming out of a digital system. But -24 is the standard. So that is, that's how you use the radar meter. And then this little thing that's been going around in a circle here, that's just kind of your history of your loudness. So I've been going over the target consistently. And this loudness range is pretty handy to know. As sometimes I'm about 6 dB lower than my loudest moments. And then I like this loudness meter here. It's got a peak meter, an input meter. This is a true peak, so I've clipped that just a little bit, but I bet you didn't even notice. And then my integrated loudness. This is kind of hard to read, to be honest. It doesn't even zoom in. What? Ugh. Zoom in. Can I zoom in? How do I zoom in? I can't. But anyway, it looks like my integrated loudness has been around 17. So both of them, -18. They're measuring the same thing. But yeah, you would use these tools to try to eyeball or earball, I don't know, what you are trying to mix. So this particular level is at a pretty good spot. Maybe I could try to process it to be a little bit louder so that, -12 pop music is about the same, but for a live stream YouTube video, I'm not working that hard. So anyway, so that's what I got for today. I was thinking about doing some other stuff with the here's our Inco automation system, but that's just gonna muddy the waters. I'll just I think when I do the presentation, I will bring this up in front of the class, in front of the group, and kind of do some practical stuff here just with Adobe Audition. I don't really need Inco. It's like only like 2 students use Inco. So I'm gonna go ahead and stop my stream. Thanks for joining me if you exist. It's fine if I'm just streaming to nobody. Don't really care. Just here for the practice. So anyway, I'm gonna stop talking and end the stream now. Goodbye.